Welcome to part 3 of the tutorials on forming images with mirrors and lenses. It'll just finish off the concave story. Drawing scale diagrams becomes an important skill. Occasionally examiners put a piece of graph paper down. Now the principles don't change, you just need to keep your wits about you as you draw it. So let's have a look at the key information. Concave side is from her face, which she sees are reflected in the spoon. The focal length of the spoon is 18 millimeters and her nose is 50 millimeters long. Draw a scale diagram so you can find the distance of the image. So let's go straight to the answer. So you may as well do it on a scale appropriate to make it easy. So you're going to need to bring with you a ruler, and if you've got a compass or a protractor, it's going to make life a lot easier. The first line I tend to put in is put in the image and where the axis is. So we've been told it's 21 millimeters because we can measure these things, and what we can do is draw this line in here and bring this straight through the focal point, and the next line we put in is this red line here, and we find the image. If you have to do any scaling, obviously scale appropriately. Don't forget to describe the image, and by just literally taking a ruler and measuring it, you'll find the appropriate size. Let's have a look at a different sort of mirror. What about convex? We'll go through a similar process as we did before and show how these images are constructed. This time we show the axes and we have a focal point, a center of curvature that is inside the mirror. And if we place objects here, we will use these focal points to actually construct an image. Let's put an image. We know that the line that comes in is exactly the same as the line that comes out. There are other lines that we can use as we did before. This one, we use this because it is a diverging mirror. It uses this angle to reflect it away. So we create a dotted line behind because we've used this element as the mechanism for sending the ray in the opposite direction. It appears to come from some hidden point inside the mirror, whereas an object going straight towards the focal point comes back parallel. We show the dotted line behind the mirror, but this is my preferred line. Look what happens. The angle of incidence is the angle of reflection. So if we measure this distance here and then we just measure that distance there, we can construct that line very easily and quite accurately. And then all we have to do is put a dotted line behind, equal angle. So combining any two rays, we find where the image is. It doesn't matter which ones you use as long as you are comfortable and confident which ones. That would be my principal one, that one there, and then just a dotted line back, and that would be my second line with a dotted line back. So this location here where they cross is where the image is. And we can see we need to describe that image. It's upright, so it is an virtual image. It is diminished. As I said, it doesn't matter which ones you use as long as you are consistent with the ones that you use. And we must use the dotted lines inside the mirror. And whichever way you feel comfortable, please use. My advice would be this one and this one. Some of the harder questions that are emerging in NCEA are actually where they give you this image and expect you to find this location. Which is a lot more challenging. My advice to you would be to practice both ways and practice scale diagrams, because any of those could come up. So the good thing is that there's only one type of image produced by a convex mirror. The image is virtual, upright, and diminished.